Okay, let's start. Good afternoon, everyone. How's the conference so far? So, was anybody in my workshop yesterday? Okay, one person. Okay, cool. So, my name is Sahil Malik, and I will be talking about JavaScript tips in this conference. You might have seen from the title, it says JavaScript top 10 tips or something. But then I saw that the talks were actually 90 minutes. So I figured, well, 10 is not going to cut it. So I started adding more, and then I started more. And first became 15 and 20. Then finally got tired of updating the title slide. So I just changed it to JavaScript tips. So at this conference, I have 4 talks. One is a one-day JavaScript workshop, which you need a time machine to go back to. So it was yesterday. I think people liked it, I hope. Then I have 2 talks today. This is the first one, and the second one is after the break in this room too. This one is more about writing code. So we'll produce bugs in this class, and the next one will fix those, I guess. So debugging is very important. Even though I never produce any bugs, I think debugging is a total waste of time. So I just write perfect code. But I think debugging is something we should learn. So that's the next talk. And tomorrow I have a whole day workshop on AngularJS. How many of us have heard about AngularJS? Right? So AngularJS is sort of becoming the de facto platform or framework for JavaScript. It's becoming very important. I have been talking with a company here in London as well to organize classroom trainings on AngularJS. So if that materializes, I'm really looking for probably tweeting, blogging about that soon as well. So if you're interested in that, if you missed that tomorrow, you might be interested in that. And in general, I'm a techie. I work on iOS, Microsoft, and JavaScript. So like a full stack developer. So let's get started. So as I said, this talk is about general JavaScript tips because we all love JavaScript, right? This is so simple. Right, this code, can anybody tell me what it does? Who cares, right? Like I looked at it, I was like, yeah, that looks pretty bad. I'll use that in the first slide. So in this talk, I'm going to be sharing a bunch of tips and tricks. My editor of choice is Brackets, but as you know, it doesn't really matter what you use for JavaScript. You can use Notepad++ or the visual Notepad, whatever you prefer. So the first trick I'm going to talk about is monkey patching. Monkey patching is a technique where somebody's given you this library or a framework, etc., that you cannot, change. But you wish to be able to tap into a particular function or something before that function is called. Maybe you want to introduce your own logic. Perhaps you want to be able to hit a breakpoint based on certain conditions, etc. So I'm going to go ahead and write a function, which is, let's say, add, and it accepts a comma b, 2 parameters. And it returns a plus b. And the theory is that this function I cannot touch, but I want to be able to tap into it, anytime calls this function. So I can obviously call this function like this, and that'll work. It'll produce 5. But if I want to tap into it, what I can do is that I can use a technique called monkey patching, in which I can save the function. Remember, functions in JavaScript are just variables. So what I'm going to do is that I'm going to save this function into another variable, right? And then I'm going to override the definition of the current add, and I'm going to say the current add changes to a new function where I'm going to say go ahead and log the arguments that were passed in, okay? And go ahead and return original add, the original add that I had saved, and apply is a way of calling a function as well, and this arguments. And what this allows me to do now is that when I go ahead and run this, and I think I have the page already running here, but I'm going to start the dev tools up here. Now what happens is that when I call add23, you'll see that it is doing a console.write line before it actually returns me a result, right? So monkey patching is an amazing technique because it allows me to tap into an existing function, a library function that I cannot change. That's one useful technique I can use. Another example is that I want to be able to insert some logic before a function occurs, or insert the debugger statement based on certain conditions, any condition, call some logic conditionally, etc. So you can see that this is pretty useful. So that is monkey patching. Monkey patching can also be dangerous. This is a technique that is being used by a lot of hackers, where especially you're downloading libraries from, say, CDN, and especially a lot of these websites, they download jQuery from a HTTP URL. I think this technique can be so dangerous that these libraries should not be served on HTTP URLs. It should always be HTTPS. But let's say if you're doing a $HTTP call, you make a post request, a cross-domain request especially, you can introduce monkey patching where you can tap every single request, send it to another URL, and then call the jQuery $HTTP, and then so the user will never notice, but you're stealing all their data, right? So monkey patching, both useful and dangerous. So that is monkey patching. Right? So that is my tip number 1, monkey patching. So second tip, this is so confusing. The variable this in JavaScript is one of those things that it can be pretty confusing, but once you understand how it works, then it's pretty straightforward. You might have seen code that looks like var that is equal to this in JavaScript. So what is this? What is that? And what is an easy way of understanding what this is? The best way to think of this is it is a pronoun, right? Like this cup is hot. So it is a pronoun, and I'm referring to this cup, right? And it can change based on context. So this is some sample code over here where I have this random object. It's got a property called tournament, data that is an array, and then a function called click handler. And inside of the function, there's some stuff going on. There's a console.log. And then I have a for each on the array, right? And down here, I call random object or click handler. Now remember, this random object or click handler over here is really, running on the window context, because that's the top level base object. So what happens in this case is that when I call the click handler and I say console.log this.tournament, because the context here is the object, this.tournament returns the masters, right? But then I go inside and I say console.log this, because now you're in here, the context changes to object window, right? So imagine if this was like a constructor-based function, like if you create a function which you can do new on, then typically this could become confusing, because then at that point during the constructor invocation, you would want to save this variable into that if you want to be able to refer to it afterwards. Right? So that is a very, very common pattern we use in JavaScript. So this can be confusing, and this is something important to understand. Number 3, understanding scopes. If there was one topic that I would say is the most important in JavaScript, that is scopes. Because scopes is the number 1 source of errors, and also the number 1 source of power when it comes to expressing yourself in JavaScript. The most important thing to understand is that JavaScript has function scopes. It doesn't have block scopes. Most other high-level languages, because a lot of people come into JavaScript with a background of C++, C#, Java, one of these languages. And then they start writing code for JavaScript, and just like C# has got block scope, we mistakenly think that JavaScript has block scope. JavaScript does not have block scope. JavaScript has function scope. What does that mean? So I'm going to go back to brackets here. What that means is that this function that you're looking at here, if I was to create a variable here, I am a variable is equal to 1. This I am a variable is not accessible over here, right? I am a variable doesn't exist here, because soon as go over this brace, I am a variable is dereferenced. So these functions can be used for composition, hiding, and code reuse in JavaScript. This is a very, very common technique we use all the time. So let's go ahead and make this a little bit more interesting. I'm going to go ahead and introduce a function inside a function, because functions in JavaScript are just variables, so they can be nested easily. So we say a function, inner function, right? So this is perfectly valid JavaScript. This is actually a very commonly used technique. And I'm going to say, so let's say return AB. I'm going to go ahead and put this in a variable, right? And I'm going to say return to return, okay? put the semicolon over here. And inside here, I'm going to do a document dot write line on to return. Now, and let's call inner function here. Now what's happening over here, this is another important JavaScript concept and demonstration, is that by doing this, I am calling inner function, which is going to call this. Now the inner function is not available outside. I cannot do add.inner, doesn't make sense. There is no add.inner function here. So effectively what I've done is that I have created a private variable inside of, think of this as a class, right? So I've created a private variable. The second thing is that this inside function has access to everything that the outside scope has. So this toReturn variable will be available inside. The reverse is not true. Inside can see outside, outside cannot see inside. So what happens over here is if I was to run this, you'll see that you get a document.writeLine 5 up there, and the way that is working is because this line of code executes and I'm able to see what is inside there. And this concept, what you're looking at over here, is also referred to as a closure, right? So I effectively have an area over here where if I declare things inside of this, they will not pollute the global namespace. Now, this function add that you see up here, this function add has got a private member variable called inner function. So if I go down here and say add.inner function, it's not going to resolve. It'll be undefined. But if I wanted to turn this into a publicly accessible member variable, this is what I have to do. Take this inner function, move it to the left, and say this dot inner function is equal to function. By doing just that minor change, and then down here I can say, then I have to instantiate it like a class. So I say var a is equal to new add 2, 3, and then I can say a dot inner function. And this is very interesting because now what I've done is that through the inner function, the outside now has access to return. So we can expose private member variables to the outside, right? So one was like a private member variable, public member variable. Anytime I do like var something, that's a private member variable. If I do this dot something, that becomes a public variable. So let's go ahead and refine this code a little bit further, or start absolutely fresh, just to make sure that we understand this very clearly. I'm going to say var outer scope variable is equal to 1. And then I'm going to go ahead and create another scope down here, where inner scope variable is equal to 2, right? So this is what I just did. And I'm going to go ahead and write a document.writeLine here for outer scope variable. I'm going to write a document.writeLine for inner scope variable. And I am going to write the same code over here and here. Now, as I mentioned earlier, that JavaScript does not have block scope. It has function scope. So these braces that you see over here, these curly braces you see here, are completely useless. They're not contributing to anything. I might as well remove them, right? They are not hiding any variables. They are not disposing any memory off for me. They are completely useless. Just to prove that, if I go down here, hit refresh, why is this undefined? Must be a typo or sequence. Yeah, okay, so it hasn't been initialized yet when this line executes, so it says undefined. That makes sense. But still, as you can see, like if you look at these two down here, everything's accessible everywhere, right? So JavaScript does not have block scopes, but it does have function scopes. So if I was to turn this into a function scope based code, I would have to change this code slightly. I would say var outer scope is equal to function. So now by doing that, this right here, that much just became a scope. Of course, I have to initialize it. Otherwise, it doesn't come into being. And then similarly, this inner scope over here, I'm going to do exactly the same here. I'm going to say var inner scope is equal to function. And let's go ahead and put semicolons here as well. Semicolons is always a good idea. They're optional in JavaScript, but you should always get in the habit of putting them. And this also needs to be initialized like that. And now when I do this, outer scope variable will be available there. Inner scope variable will be available here. And this is not going to work. Right? So now I have effectively limited the variables, depending upon where I declare them. Now they resolve, but if I was to write document or write line, inner scope variable outside here, it would probably give it undefined. So this is the concept of scopes in JavaScript, and it is very, very important to understand. Closely connected with scopes is the concept of closures. So I'm going to simplify this code a little bit. And let's go ahead and remove, OK, let's keep that. And let's get rid of all of this. And I'm going to replace this line, my custom logic. OK? Now, by doing this, effectively what I've done, because one of the golden rules in JavaScript is that don't pollute the global namespace because you have only one. If you have a variable called I and I have a variable called I, we're going to step over each other's toes. Right? I'm going to accidentally overwrite your variable. You might accidentally overwrite my variable, and that's always a bad idea. But by doing this, if I was to declare I inside my scope, then I'm pretty safe, right? Because you cannot peek into my scope. I have private variables in there. So this right here, this sort of invocation that you're seeing over here, gives me my own custom scope. And I can actually simplify this logic even further. So rather than having to declare a variable like outer scope and then have to call that down here, I'm going to get rid of this line. I'm going to get rid of this line. I'm going to go ahead and put braces around this. And that's the variable. It's a function, so I'm going to go ahead and call the function. And this piece of code that you're looking at over here is something that you will see over and over and over again. In a lot of JavaScript libraries, this is a self-initializing scope. So this is a function that as soon as you hit F5 and the page loads, after the DOM has been parsed, the JavaScript function is going to get called, and anything you do inside of here is your private area. This is how we should write JavaScript. We should always start with a self-initializing scope or self-initializing closure like this. Right? So you might have seen this, one of the things I don't like about JavaScript sometimes is that it's full of braces, like parentheses, braces, and matching them is so hard. Especially when you look at code like this and we copy paste off of Stack Overflow. But now it's so clear. You look at this, you're like, yeah, I know what this is doing. This is a function that I need to initialize. I put this in a variable, and then I call it. And that makes total sense. Right? So this is how we should be writing JavaScript scope. Now, I said a moment ago that this does not kill a scope. It has to be the ending brace of a function. So let's take this a little bit further. I'm going to say function, some function. I don't need arguments. Nobody likes arguments. And say for, and let's say I is equal to like this, iteratable dot length, so less than 100. Let's go over here, 100. And do some stuff. Now, there is a big problem with this piece of code. Right? And the problem is that if I was to go and run this, okay, so the function was called some function. So let me just go ahead and run some function. And then I check the value of I. Wow, it's a global variable. And I was an indexer over here. Now what just happened over here is that I made a little mistake. Instead of saying for I is equal to 0 to I less than 100, and this is code that we see in like C# all the time. Instead of doing for I is equal to 0 less than 100 and so on and so forth, I should have done var I. So if you forget to put var, it makes it global, even though it's inside of a function. And this is something you have to be very, very careful of. Right? So if you forget to include var, it makes it global. It declares it on the window object. And a connected problem with this is that sometimes we like to write code like this. Var a is equal to b is equal to 1. And this is problematic too, because what this will end up doing, this is the same as writing like this. So it doesn't automatically put a var in front of over here. Now the new builds of Chrome do that, but the older ones don't. Until very recently, they don't. So you have to be very, very careful of this, right? Now, if you want to save space or whatever, you could definitely do this. That's fine. But always use var and always use semicolons. Very, very important. Okay? Now when I do this, okay, another thing to remember, as I keep saying, we've got function scopes. We don't have block scopes. So this right here is not a function scope. That's a function scope. This line 2 to 4 are not a function scope. That's a block scope, which means over here, if I did a console.log on I, and I call some function, I have to call it, of course, some function, the variable I still has a value there. Because the variable I doesn't get dereferenced until the function exits. The block doesn't matter. And again, this behavior is different than C#. So, this is something that we have to be careful of. Okay. Any questions so far? Any of these tips new to anybody? Or this is like repeated? You already knew this. We always. Okay, cool. At least some. Hopefully by the end of this presentation, everybody will have something new that they can take away. I am hoping. Okay, another important thing that we have to keep in mind when it comes to these scopes is that, like I had that inner function, and that inner function was holding a reference to the toReturn variable. Remember that? And that's how I could do var a is equal to new add, and then I can say a dot inner function, and it returns me something. It returns me the value of that toReturn variable that I had created. But behind that is another insidious thing that we need to remember. And that is that for it to be able to return me the value of toReturn, it has to hold a reference to toReturn, which means it is consuming memory, right? So the important takeaway over here is that if you don't dereference variables, then what happens is that all the variables that the inner function is referencing of the outer scope, those still remain in scope. In fact, you cannot be sure if it's just the function, the variables that you're referencing, but it's also, there's some possibly some calculation going on, etc. So they just take the safe approach of keeping the entire outside scope in memory until the innermost scope hasn't gone out of picture. So it's very easy to take the innermost variable, lose it somewhere, and then your application grows. Remember, these browsers are like the operating systems like DOS was. There is no multi-threading. Everybody's on their own, and you can keep chewing up memory. So here's an example. So remember, closures can cause memory leaks, because closures can have memory leaks when the inner function holds a reference to the outer function's variables. So the inner function can access private variables defined in the outer function even after the function has returned. Right? Otherwise, the thing just won't work. So they have to do this. And the problem with this is that you might run into examples like you see over here. Because over here, I've done this in a set interval, timeout. Every 1,000 seconds, go ahead and call this function. As it keeps calling it, it is going to keep creating a chain of these long strings, which is 1 million bytes, and it's going to keep chewing up memory. If you run this in Chrome and run this for a while, you'll see your memory usage keep going up. That's because of garbage collection. All modern browsers have garbage collection. If you keep this running for like an hour, you'll see a definite trend that's keep going up and up and up, right? So that's another thing to be careful of, right? Next tip. This looks like Chinese, but I assure you it isn't. Equal to is not equal to, double equal to is not equal to, triple equal to. In JavaScript, there is this concept of double equal to, which we have borrowed from all other languages, where we can say var I is equal to 1, and then I say I equal I in a string. And this evaluates to true when it shouldn't be true. One is a number, the other is a string. How can they be equal? So always in JavaScript, always get in the habit of doing a triple equal to instead of a double equal to. So if I was to do this, it says false, but if I was to pass in a string, it evaluates to true, right? So it's like they're really, really equal. And then that's what we have to keep in mind. Now, connected with this are a couple of other interesting cases, is something like this. Like, let me increase the font size here a little bit if I can. Right, let's do that. So, you have console.log, false equals 0. Because, in JavaScript, like any other language, there are some conditions that are falsy, some conditions that are truthy. Like nan is falsy, 0 is falsy. So if 0, that's going to be false. So similarly, if you say false equals 0, that'll be true. They say console.log, null is equal to undefined. That will also evaluate to true. All of these return characters, /t, /s, tab, return character, new line, they will also evaluate to true. And obviously blank string will also evaluate to 0. And this looks very obvious because this is what this is, a canned example, right? There's a canned example, but you'll see that when you're writing code and code is calling more code and you're generating code on demand, that's how JavaScript is. You run into these situations quite a lot. Similarly, you got this weird thing called nan. Nan stands for not a number. Not a number, you get that in many circumstances. So like over here, you say console.log nan is equal to nan. False. Nan should be nan, but it's not. But you say triple equal to, that's also false. But you say is nan nan, that's true. Right? So these are things that are not obvious, not straightforward, but we have to keep them in mind when we are using JavaScript. And obviously this is very obvious, but sometimes it's very easy to make this mistake. Equals is a set equality operator, as in it will set the value. So double equals will compare, triple equals is what we should be using. So just get the habit of triple equals. Next point, use semicolons. And this sounds very obvious, but when you have all these parentheses and braces and all that, it's sometimes you forget to add a semicolon. And this leads to bugs. And this is an example of a very common bug that you can very easily introduce. For instance, there is a standard which says where should we put the curly brace in our code? And some people like to have the curly brace over here, and some people like to have the curly brace over here. Now, which is better, which is not? It's like coding standards, which is like driving on which side of the road. So pick left or pick right, and everybody should do the same. Like don't mix and match, otherwise you're going to have accidents. But in this case, if I have a return like this and say like that, this is going to produce a problem. Because what this will do, see this function returns something, JavaScript will put a semicolon here for you. Because it will think you forgot to put a semicolon. So this function will always return a null. Right? And that is why mostly in JavaScript you will see people prefer to write code like that. So that's another thing to watch out for. Semicolon insertion. Number 7 is hoisting. Hoisting is this concept in JavaScript where all the variables that you define, the JavaScript compiler will take the definitions of all of those variables, not the value assignment, but the fact that you have defined that variable. It'll take all of them and it'll stick them at the top of your scope. And the advantage of that is that we don't have to keep tabs on, did I declare this function first or did I use this function first? Did I declare this variable first or did I use this variable first? You can declare the variable anywhere you want and you can use it anywhere you want as long as they're within the right scope. Now, that's convenient, but that can also create problems. Now remember, it only moves the declarations of the functions. It doesn't actually move the value at the top. So if I say var I, and that's what I left it at, then I can see the fact that there is a variable called I, but until I give it a value, it's not going to actually see that value. Right? So that makes sense. Var I is equal to 1. If these are two separate statements, and if I was checking the value of I anywhere, until I set I equal to 1, it will not have a value. That's obvious. But the fact that I have a variable called I means that I can use it. This is useful in functions especially because I can call that function from any place. But this can create some problems. And the kind of problem it can create is let me get to the code, like this over here. What I'm doing over here is that I'm running this in a loop, and inside of the loop, I'm saying elements on click function, console.log, you clicked on this element number. And you'll be surprised to see that if you run this code, all of them will say you clicked on number 10. Because what it did is that it took this declaration of the function and it put it at the top. You did not get 10 functions. Everybody got assigned to the same function because that piece of code, practically speaking, has been moved to the top. So the right way to do this is that instead of putting a function in here, we should create a function factory, a function that gives me another function on demand. And that is what I should be assigning things to. Right? And what happens if I have a function inside an if block, in a condition of an if? Like say, if I create a function inside else, does it get hosted? The answer is, it depends on what browser you're using. Some browsers will not move it. They will understand that you have that inside of an else block. Some browsers will move it to the top. Unreliable code. So best practice, don't create functions inside if, else, or any one of these loops. Always put functions outside. Great. Number 8, I've sort of already covered this as a global madness, which is always declare variables. Because if I was to write code like this, var not global is equal to 1, global is equal to 1, then a global variable, even though it's inside of a closure or a scope, it will end up getting created on the window object. Right? So always use var. Again, I already covered this. Accidental globals, don't write code like that. Number 9, CDN failures. So one best practice, always, if you're using CDN, always use the HTTPS URL. Because HTTP is just too easy to hack. HTTP, somebody can set up a DNS hack so easily, and they can redirect you to their own version of jQuery, in which they can steal all your requests, for instance. But sometimes what happens is that the browser may not be able to download jQuery because maybe jQuery is down, your internet provider is having a bad day. And in that case, whenever you load things from CDN, you should do defensive coding. So this is one very important word I just used, defensive coding. In JavaScript, anytime you write code, it's like, just remember you're in the middle of a wild jungle in the middle of Botswana, and every creature out there is to get you, right? And every line of code you write, you have to think, how can this be broken, right? So when you're loading things from the CDN like this, always write code like that. It says window.jQuery. If it doesn't exist, then load a local copy. So always do defensive coding. And this defensive coding, this word applies to so many places in JavaScript. For instance, that function that I had, which was adding 2 numbers, that right there was a function that you can break very, very easily by passing strings into it. Right? It will return you, well, it'll concatenate the 2 strings. It'll certainly not be reliable, right? So you have to write code over this, and type of A is not equal to number, type of B is not equal to number. And even then, I could pass in an undefined and still break it. So say type of is not a number and it's not defined. This is the habit we have to get into. Especially if you're writing code that is a library that is going to be used by a lot of functions, this is how you have to think of it. Number 10, understand type-off. Type-off is reflection in JavaScript. I want to see what kind of variable it is. It is a common misconception that JavaScript doesn't have types. Definitely JavaScript has types, but JavaScript is loosely typed. So when I say var I is equal to 1, that's a number. JavaScript has numbers that are 64-bit numbers. But sometimes JavaScript likes to convert them to 32-bit for efficiency. When it does bitwise operations, it does that. Still, it has numbers and it has strings. If I was to put quotes around that 1, then that becomes a string. If I was to put square brackets around it, it becomes an array. If I was to put curly braces around it, it becomes an object, right? So JavaScript has got objects, different kind of units, strongly typed. And type-off, unfortunately, is not very reliable. So type-off of an array returns object. It doesn't say array, it says object. And the problem with that obviously is, if you want to iterate over an array, you would say type of, if it's not array, then I'm not going to iterate over it. But it's not going to work. Now, ECMAScript 5 has introduced a method called isArray. But a lot of even newer browsers don't have that implemented yet. So we use a technique called polyfill. So you say if array dot prototype dot isArray equal undefined, then array.prototype.isArray is equal to new function, and in that you write your logic for checking whether or not it's an array, and that's what we use. You cannot override or supply a definition to type of. That's not going to work. But you can definitely override the functions on a prototype. So type of is unreliable. Another thing that you see over here is that it says type of null is an object, which is completely wrong. How could null be an object? Null is null. Null is nothing. If you can make null to be 1 or a string or an object, but certainly null itself is not an object. But type of null will return an object, which could sometimes break your code as well. Type of a decimal returns as number, because it's important to realize that in JavaScript you don't have numbers. Well, you have numbers, but you don't have the concept like integer versus double versus float, or you don't have those. Everything is a number, and all of these numbers are represented with a 64-bit number, and that goes up to like 9 quadrillion. So if you want to see this, it's like there's an object called number, and it's got these properties on it, like max value. And that's like there's a floating point arithmetic, but then I can say max safe value without losing any precision. And this is 9 quadrillion something something. So if you need numbers greater than that and you need precision, JavaScript is not the right language for you. Luckily, that's a lot larger than the US debt, so we're okay for the next year or two. And if I do something like number dot max safe integer plus 1. So it seems to increment it. Interesting, because it used to be just return max value. But anyway, should be infinity, right? Anyway, number 11, parseInt madness. There's a method inside of JavaScript called parseInt. ParseInt. And what that does is that if I got a number as a string, it returns me the number as a number, not as a string. So if I passed in 12, it will return me 12. Now this will work in Chrome. If I say 08, it returns 8. But if you try the same thing in Internet Explorer, this will return you 0. Because it looks at this leading 0, and it thinks that you're working in octal numbers, not in decimals. And that's how it will evaluate the number for you. So again, defensive coding, always specify the radix when you are using parseInt. Otherwise, in some browsers, this will break. And this leading 0 is actually, you might say, well, why would I ever do that? Dates. Dates is a very, very common example where you'll see these leading zeros quite a bit. Anyway, so if I say, let's say 12, and that returns me 12, and that's pretty obvious. But if I say 12 monkeys, still 12. Okay? What if I say a dozen monkeys? Not a number. What if I say monkeys 12? Still not a number. So what's going on over here is that the way parseInt works is that it doesn't say, well, this is not a number. That's not how the logic works. It says, I'm going to start looking at the character starting from the first digit onwards, and if I find a number, that's great. If the first one is not a number, then I'll just return not a number. But then I'm going to continue and keep parsing until I find a not a number, and I'll stop and I'll return you a number. But if the very first character is a string, then I will return not a number. So this is also not quite like what we'd expect in C#. In C#, this would throw an error because it's not a number, right? But here we get 12. So that's another example of where JavaScript is slightly weird. Okay. So parseInt isn't exactly like how we expected either. Number 12. Non is not roti. I think in London this probably makes sense. But So as I said, I think I've already covered this. If I say type of nan, it returns me number. And there's a lot more nan madness going on. Type of nan is number, and then if you say nan equal to nan, that gives you false, which doesn't make sense, right? X is equal to nan, okay, but then you say x not equal to, and that evaluates to true. So if this is false, why the hell is this true? But that's how JavaScript works. And again, there's something we have to keep in mind. The plus operator is totally weird. The plus operator in JavaScript is different from the minus operator. And then the difference is not just addition and subtraction. Plus operator can work both on strings and numbers. When it encounters two numbers, it will add them mathematically. But when it encounters two strings, it will concatenate them. But what will happen if I use a plus operator with a string and a number? What does it do then?
Make it a number.
Number. How many people say number? How many people say it'll concatenate like strings? It'll concatenate like strings. So again, but how the hell are we supposed to remember all this? But that's what it does. So if I say var I is equal to 1, var j is equal to, like this, I say k is equal to I plus j, this will become 11. However, now this is the really weird thing. If I did j plus plus, that will return me 2. I'm not kidding, you can try this, right? So, this is not a ripoff on a popular U2 song. This is a real JavaScript problem. There's a statement in JavaScript called with. And with changes its behavior depending upon the values of your variables. Right? Don't use with. If there's one thing you can carry away from this slide without understanding it, just don't use with. Because it's confusing, it's going to produce unreliable code. But what does it do? Var obj is equal to, I'm creating a new object, object.a is equal to 3, .b is equal to 4, a is equal to 1, b is equal to 2, and so with object a is equal to b. Now what is it doing here? Is it saying obj.a is equal to obj.b? That would be true if either one of these is not undefined. And again, when you're looking at these lines of code, it's easy to understand it. But this obj variable could be passed into you from 3 levels deep or more. Probably from an anonymous function embedded deep inside parentheses land, right? And that makes it extremely hard to debug as well. So don't use with, not to mention the with statement is slow. So some people say, well, I like with because I don't have to type as much. And there is a very good workaround to that as well. Here is what you do. If you don't like to type with, so I'm going to say var very long variable that makes my hands hurt as I type, okay? And then I'm going to copy paste, but let's say if you had to type all this, for some reason the control key was broken, like, you know what I mean, right? This is a very bad justification for using the with variable because you can always do something like this. Var o is equal to that, and say o dot and o dot. There is almost no justification for using with. Don't use it. So that is the with variable. Don't use that. Number 15, using strings as functions. It's a bad idea. And that's basically eval. When I say eval and I pass in some code as a string, that's usually a bad idea. Because eval, number 1, is very slow. Number 2, there are tools called JSLint, which will look at your JavaScript and they will tell you if you're making any mistakes in your JavaScript or any best practices, etc. You should use JSLint. It's built into most tools. This brackets tool that I'm using, as I'm writing the JavaScript down here, it tells me it's linting it, well, it was somewhere. Yeah, I don't know where it is. Here it is. So right here it's saying I should use the use strict statement, which by the way is another tip that's not in slides. These days you should always do that. Use strict. And the reason for that is newer browsers understand this. Note this is just a string, so it's backwards compatible. It's not going to break your code in older browsers. But by putting use strict over there, if I do that, it will basically bomb. It won't work. It will require me to put a var in front of it, right? So it prevents me from making some mistakes, and it does a whole bunch of other things too. So anyway, let's come back to eval. Eval code, so JSLint cannot understand it, and that's not good. The code is harder to read and understand because typically inside of here, if you're writing a function as a string, that's going to be a problem because the function, maybe let's say the function is rendering some HTML, and you're going to have to worry about escaping these strings over and over again, and it's just going to get unmanageable. So it's harder to read, harder to debug, harder to understand. It is slow, and it is injection attack prone as well. Right? So don't use eval. There are some very special circumstances in the current version of AngularJS that require eval, but they'll be removed in Angular too. So there's some exceptions where we still do eval, but at least try and minimize it. Number 16, and this might be very, very obvious, and that's called JavaScript reserved words. And there are a whole bunch of words inside it like abstract, arguments, Boolean, break. These are words that are part of JavaScript syntax. Right? Don't use these as variable names. And obviously your code is not going to work if you use them as variable names. But some of these new ones that are marked with star are being introduced in ECMAScript 5. And then there are some that are being introduced in ECMAScript 6 that are not on this list actually. And what's going to happen is that they will become reserved words in the future. So you shouldn't use them. Like the word class. Class will be introduced in ECMAScript 6. And if you write class now, it'll work now, but it's going to break later. Right? So that's also something to be careful of. Don't use these reserved words. There's some more reserved words. And objects on an HTML page should also be considered as reserved words. Now, this might seem very obvious. You're like, okay, any code I write, if I write a variable, I will check against this list and I'll make sure that it's not a reserved word. But let me show you another interesting example, because these reserved words sometimes come in, they bite us where we least expect them for them to bite us. So let me go ahead and say var input is equal to, we are having a great time at DevWeek. Are we not? Right? Okay. So I want to be able to write a function that is going to create an array of unique words, and it's going to basically count the number of times any particular word appears in the sentence. So the word are, for instance, appears twice. And that's something that I'm going to remove that for now. That's something that I want to be able to track. So I'm going to go ahead and write this function. I'm going to say function word monkey takes an input, okay? Or actually just takes a word, because down here I'm going to call this, I'm going to say var input array is equal to input.split. And let's go ahead and split it with a space, so all the words are separated into a string array. And I'm going to say input array dot for each, and I'm going to say function word, okay? And let's go ahead and do that. Did I match all the braces? I did or not? I think I did. Let's run with it anyway. It looks wrong. Hold on. Yeah. Okay. Yes. I got it like that, right? Okay. Thanks. The word monkey word. And to keep things simple, I shouldn't be doing this, but let's go ahead and create a global variable, whatever, word count, like this. And inside here, I'm going to go ahead and start calculating this. I'm going to say if word count, and it already contains the word, then word count word plus equals to 1. Else word count word equals to 1. semicolon. Okay, so let's go ahead and run this. So input is equal to this input array, then I run for each. Okay, let's go ahead and run this. So I run this and I check word count at the end of this. And it returns me an empty array. I screwed up. Where did I screw up? Let's see. If word count, where word count is, hold on, that's where I screwed up. It's not an array, it's an object. Refresh, word count. Yeah. So it says we are DevWeek are. There's a problem in my logic. R should have appeared twice. I think it's the string caps. Let's go and refresh. Word count. Yeah, so R appears twice now. Okay. All right. My code is working. Ship it. Done. But users are very clever. What they do is that they're going to replace this with a string because they think, well, I'm a programmer, I should know this. So I'll say objects are instantiated using constructors, aren't they? Okay? Or actually a constructor. And this might give you a hint of the kind of problem I'm after. Bam. Let's see what this does. Hey, hold on. This is supposed to work. Wait, there is a dot here. Let me get rid of that dot. Word count. And whoa. That doesn't look right. So based on the string input, my logic broke because I had a reserved word in the string. In the string, in user input. So remember, you're in Botswana. Every animal out there is to come and eat you. You have to be defensive. How would I fix this? In the input, I would check and see if the passed in input is actually type of string. That's it. If it's not string, then return or throw an error. Right? That's what I would have to do. Defensive coding. Okay. Events are obviously, don't use these as variable names. JavaScript is case specific. So, if you don't want to use on mouse server, you can case specific it and make it underline, whatever. So those are things you can do. One other weird thing you see over here, as I confused this side, when I wrote this code, I made this an array. And this is another interesting thing to remember is that an array is an object in JavaScript. Array.prototype, if you go through the prototype chain of an array, it is an object. Right? So that is why type of array returns me an object, which means that any object, if it has a property, like I've got a person.firstname. So I can refer to that property as person.firstname or person square brackets firstname. And both of them are equal. And that's how I'm being able to do this, because remember, arrays, think of arrays as objects where the properties have to be 0, 1, 2, 3, 4, nothing else. But if you need a property name as a string, then it has to be an object. So array is just a special kind of an object. So solution, you could do this, or you can just use for in, because the for in loop assures and requires homogeneity across all the elements that are returned. You cannot run for in on numbers and booleans and all. It has to be similar. Number 17, avoid multi-line string literals. Sometimes in C# we have the syntax where I can say @string and then I can write the string in multiple lines. JavaScript has got a similar syntax, which you should never use. Why? Now I'm going to show you two pieces of code. I'm going to tell you one of them is broken. And you have to tell me which one. One of these won't work. Can you tell me which one? Look hard. There's a difference between the two. There is. I assure you there's a difference between the two. Let me know when you give up.
One of them has lots of
Where are the spaces?
Just saying.
Yes.
Third training space at the end of the first line.
You're right, absolutely. Good, very good. So, can you tell the difference now? And this is why we shouldn't use multi-line strings. Like if you're just reviewing this code, and if you didn't actually put your cursor there, you wouldn't even know there is a problem there. The other problem with multi-line strings is that they break indentation. And indentation helps us understand code. But if I was to indent, like if I didn't have a trailing space here, but if I indented this all the way in, then my string would have all of those spaces. Just don't use multi-line strings. They're just a bad language feature. Right? So what's the workaround? If I did want to break apart a string into multi-lines, just use plus. Break it apart into multiple strings, use plus to concatenate them. It's almost the same result. Few nanoseconds slower, but it really doesn't matter. So one of the interesting things, we say, like sometimes you get these pictures on Facebook or forwarded in email where say, here's a little chip that was 256 megabytes 5 years ago or 10 years ago, and here's another one that's 256 gigabytes now, and they're the same size, right? And like a 5 megabyte hard disk used to be the size of a washing machine in the 1960s. So, and people brag about that, like in the last 10 years, storage has gone up by a factor of 1,000, which is a lot. Now, here is what really sets that upside down. JavaScript engines have gone up 10,000 times in performance in the last 3 years. And just trust me on this, I have a graph which I stole from somewhere on the internet that actually shows that. So when programmers start worrying about these nanoseconds as concatenating these strings, etc., is going to take longer, seriously, don't worry about it. Right? Don't worry about it. Those nanoseconds, it won't even be nanoseconds, probably be lesser than that. Number 18, clean code. How much time do I have left? Okay, I'm doing okay on time. Actually, I'll finish sooner. Write clear code. This line of code is actually this, which might not be that obvious by looking at it, right? So you can learn all of these tricks and start writing really cryptic code for absolute job security. Or you could write clean code and be a nice person, right? So you can say if A, B, it is not like that, it is like this. Just use braces. It's a lot clearer. Your intent is a lot clearer. Always use braces. Why not? Number 19, declare statics outside loops. Right? Now this is an example of a static which is not going to change. If it was any other compiler that takes a long time to compile, like C#, Java, etc., those compilers are smart enough that they look at this variable and they say, you know what, this is really not going to change no matter how many times you call it. So they will take this and they'll put it at the top as an optimization thing. JavaScript doesn't do that. Because JavaScript, when you load a web page, you want the page to be available right then. So they don't want to introduce a long compilation loop, right? So they'll never introduce this sort of optimization. So when we write code, we have to introduce this optimization that if we are writing a variable like this, put it up here. Especially if it's inside of a slow loop. And last tip, use JavaScript. It's not as bad as you think. Okay, when does this talk get over? What time? 3:30. I still have half an hour. Okay, so I have a suggestion. For the rest of the 30 minutes, how about I introduce you to ECMAScript 6? Is that okay? Okay, let's do that. And a little bit of TypeScript in ECMAScript 6. So obviously you see that JavaScript has got some issues. And the issues are mostly because this language has an interesting history. It was created over a period of a week by a guy called Brandon Eich. And then it was created with the intent to kill Microsoft. And then there was this other company called Sun Microsystems that created Java. And back then it was called LiveScript. JavaScript was called LiveScript. And this is like in the mid-90s. And then Java, rather Sun and Netscape, because Netscape is the company that created LiveScript, they basically shook hands and they said, look, rather than having Microsoft play us against each other, why don't we combine forces and both of us together will fight Microsoft. So the idea is that LiveScript could run everywhere. Everything would be served through the browser, so therefore operating system is not important. Whereas Sun Microsystems said that, this language Java, write once, run everywhere, and therefore Microsoft is no longer important. Well, apparently Microsoft is still around, so they screwed up, but still. They joined hands, but then the issue was, well, we have two stories of doing the same thing, like Java versus LiveScript. What do we do? So somebody had a brainwave, and they said, how about we call LiveScript JavaScript, right? Let's call it JavaScript, and we'll pretend that it is Java's young retarded brother. And that way our messaging is consistent. And that has been confusing recruiters ever since, right? Do you know Java? Oh, you must know JavaScript too. Anyway, so, and then from that point onwards, basically, then Microsoft looked at JavaScript and they thought, yeah, this is bad news for us. So we need to have something like this in Internet Explorer. And then what they did is that they reverse engineered JavaScript, but they couldn't call it JavaScript because back then Sun was suing coffee shops because they were using the word Java. So Microsoft decided to call it JScript, right? And then they also had something called VBScript, which really never took off. And then as time went on, Netscape and Microsoft said, all right, time to kiss and make up, and say, so let's make this language a standard. They took it to ECMA, and they basically turned it into a standard that was called ES3. But they needed a name for it. So they said, let's call it WebScript. Yeah, that doesn't sound good. Well, we don't know what to call it. So for now, let's call it ECMAScript, for now. And that was 2001. 14 years later, we're still stuck with that name. So JScript, JavaScript, ECMAScript 6, they are all the same, right? And right now, the latest version of ECMAScript we have is 5. That's what most modern browsers implement. And the standard that is ratified, you'll start seeing in browsers by the end of this year, is ECMAScript 6. ECMAScript 6 looks at what was there in the current JavaScript. It wants to keep it backwards compatible, but it wants to give you new features that will help us write better code. But obviously, what do we do in the meanwhile? So in the meanwhile, Microsoft introduced this technology called TypeScript. And TypeScript, what TypeScript does is that it gives you the advantages of like C#, right? So if I was to create a function and try and call the function and have a typo in there, TypeScript will warn me. It'll say, you're trying to use a function before you've declared it, and immediately I'll know what the issue is. TypeScript compilers plugged into Visual Studio also allow me to do refactoring. Right? If I select a variable name that's a function name, it'll select all of them. I can rename all of them together. Right? So those are the advantages of TypeScript. Obviously, TypeScript has got a little problem that there's a compilation step. But TypeScript compilers are available as EXEs. It's called tsc.exe, or they are also available as full JavaScript. So when TypeScript loads inside of your browser, it generates JavaScript specific to your browser. And they took this concept a little bit further. And they said, why don't we provide ECMAScript 6 features today? So you can start writing ECMAScript 6 today. We will just convert it to the JavaScript engine you have. And that's beautiful. That's amazing. Except only about 20% of ECMAScript 6 features are available in TypeScript as of today. Still better than 0, but just 20%. So one of the things I would say at this point is that TypeScript so far had just been a toy because nobody was using it, maybe because it came from Microsoft. But recently, Microsoft and Google shook hands and they said that the language for AngularJS 2.0 will be TypeScript 2. And they gave up @script, they gave up CoffeeScript, and it's going to be TypeScript 2. TypeScript 2 is not out yet. TypeScript 1.5 is what's out. But TypeScript is one of those things that I would keep an eye on. It's going to evolve. It's going to be really amazing in the future. So with that in mind, let's look at ECMAScript 6 and let's look at TypeScript as a basic introduction to both of these. Okay. So how many of us in here are C# programmers? Cool. You must be familiar with Lambda functions, right? What are Lambda functions? Lambda functions are shorthand for writing a function. I want to write a method, I can express that as a Lambda function, and it's a quick way to write a function. So what I'm going to do here, I'm going to go to a site called TypeScript Playground. So another thing I want to talk about TypeScript is you can just take a current JavaScript file, rename it to .ts, and start reaping the benefits of TypeScript today. You don't have to actually write TypeScript today, right? So right there, if you rename your file to .ts, start using TypeScript, and you'll gain all the advantages of TypeScript today. So as you see over here, what I did on the left is I typed ECMAScript 6, also TypeScript, for this example. And on the right-hand side, it converted that into old-fashioned JavaScript. Right? So what it did, this is the code it wrote. Var hello world greeting, this is just like a Lambda expression, right? This is the same as writing a function like this. And this is the first feature in ECMAScript 6 where I can write code like that. What if I actually want to try out ECMAScript today? Browsers don't have this right now, but you can get to it using ES6Fiddle, I believe, ES6Fiddle.net. Here you go. So I can write ECMAScript 6 here, and I can run it over here, and I can start learning it today. It's not available in browsers as of now. All right. Another thing they've introduced is the concept of classes. Again, this translates it for me so I can see what's going on here. I showed you how to write a function enclosure that can work like a class. So this is a class called animal. Look, ECMAScript 6 has got strongly typed variable names, like isDangerous is a Boolean, and TypeScript, when I double-clicked on isDangerous, it selected this down here as well. I can choose to right-click, I can choose to rename symbol. And these TypeScript compilers are built into Sublime as of now, and brackets and Visual Studio. So you can get all of these features with JavaScript today. So I have isDangerous Boolean, but in the current world of JavaScript, there is no Boolean except unless I assign it, so it did that for me. Right? So it automatically created a class out of this. Even this data type specification is not just available on properties, it is also available on parameters of a function. And if down here, if I say var a is equal to new animal, and here if I pass it, IntelliSense, but if I pass in a number which doesn't match the data type, I get a little tilde here which tells me that there's a problem here. The data type doesn't match. These are the things we like about C# and hate about JavaScript. Similarly, I have the ability to create classes that extend existing classes. It tells me it can't find animal because I removed it, but the code is still valid. And then I can call base classes constructors using this keyword called super. Right? Super, doggy name, and then down here I can go ahead and instantiate it. On the right hand side, you can see it generated a whole bunch of JavaScript that frankly I don't even have to look at. Right? As it gets more complicated, I'm probably not going to look at it. But if you actually look through it, you can see what's going on here. See, __ prototype is equal to b.prototype. It is basically assigning the prototype link chain, and that is how inheritance works in JavaScript. So that's exactly what it is doing. It's perfectly valid JavaScript. Dog.prototype make sound. This is a function that is on dog's prototype, not on animal's prototype. It understood that because I have actually created the function inside here. Right? So that is feature number 2, classes. Feature number 3, and this is really nice. Remember I said JavaScript has got block scopes, not function scopes? Did anybody catch that? No, it's got function scopes, not block scopes. I was just checking. So it's got function scopes, not block scopes. But this let variable allows me to have block scopes for anything declared with let. So down here, this y will not be accessible, or it's not going to mean anything. So again, this is going to help me to write clean code. Now this is where TypeScript ends, because it doesn't have these features implemented as of now. They will implement it later, but this will work over here. So y is not, say, I'm supposed to get an error here because y is not defined, but if I was to move this y inside here, then it should work. Right? So best practice, ECMAScript 6, when it comes out, when you do a for indexer, instead of using var, use let. Because then the variable will immediately disappear after your for loop ends. Very cool. So that's the next feature in ECMAScript 6. Next, method shorthand. Method shorthand is just an easy way for us to be able to write new methods. Var new object is equal to new method input value. So this syntax here is the same as that syntax here. Just a little less wordy, but it means the same thing. Great? Okay. Next feature. Templatized strings, which is multi-line strings done right. And this was a feature first introduced in Swift, that new language that Apple created. So Swift has got this concept where I can create a string with replacement holders in the middle. And then C#, actually, I ran into this guy called Mads Torgersen. I've known him for many years. He works on the C# team. And I asked him, what do you think of Objective-C? And he started laughing. But actually, him and me, our opinions are the same about Objective-C. That it's a language that's 30 years old. It's very powerful, some good things about it, but it needs to improve. Luckily, after Steve Jobs died, people at Apple felt the same way. So they created Swift, which is pretty cool. So finally, they have a decent language. I like Swift. I think it's a great language. There's some good things in it. It's not, by far, it's not a complete language. It doesn't have exception handling for one. A lot of other things, but that's a different topic. But one good thing that Swift introduced before most other languages is ability to write strings where in the middle of a string, I can write a variable. And then C#5 copied it shamelessly. And ECMAScript 6 said, it's a good idea. Let's use that. So this is what they did. So if I was to run this, it'll actually write out my full name like that. So this is another feature available in ECMAScript 6. This is another feature, destructuring, which is going to save you loads of time. And ignore that for now. They've introduced a syntax that says ... And what this will end up doing is that it'll create 3 variables. A and B will have values 1 and 2. And the rest value will be an array of everything that is left at the end of it. And where will you find this really useful? In functions. You can use that ... even in functions, because in JavaScript, the parameters that you specify in front of a function are just to help you out. You don't have to pass that many parameters in. You can pass in less, you can pass in more, and the function will still get called. But when you do ... it gives you a convenient variable to capture everything you hadn't thought of. Currently, we can do that using the arguments variable, which is not an array, but you can convert it into an array. Right? But this ... variable is an easy way for me able to deconstruct a bunch of variables coming in. Now, you might think that, okay, this is trivial, but imagine how powerful this is. If I was to write a piece of logic that swaps 2 numbers, A is equal to B, B is equal to A, I could achieve that in one line. A comma B in square brackets is equal to B comma A. That's it. It'll swap them. And there are a lot of other such interesting usages. Now, here's another practical usage of this, that I have a contact form up here on my site, Actually, it's www. It's not on blah. www. That's the right URL. So I'm using some regex, which is what I call as a write-only language, because once you've written it, you can't understand what it does. And then it's going to return you a string array, and that string array, I can easily pick out, the parts that I'm interested in. Just like that. Right? So this is destructuring, also new in ECMAScript 6. Pretty awesome. Next, the concept of default values. See, even they like it in the room next door. The concept of default values is that when I'm calling a method, and if the caller forgets to specify a value, then I can give it a default value. Like here, if I pass in undefined here, so I don't have to keep checking is undefined. I can give it a meaningful value in my functions. And actually where this is really useful is that if I was to swap these two, then effectively I have method overloading. I get two methods, one with a default value, one without a default value. And how many times have we written functions like this, where we have one function and another function, this function calling another function with more parameters, and then you keep plugging in default values. You don't have to do that anymore. You can just write default values like this, and this will work. And the default value is a string. It could have been a number. It could have been a date. It could also be a function, because functions are just variables. Now you see how powerful this is. Right? That's pretty cool. Okay, default values. Next, new cool thing in ECMAScript 6, which is the concept of a iteratable. Writing iterators in JavaScript is very difficult because you can't do it. There is no concept of an iterator other than an array or an object. You can't write your own iterators. But here, I have the ability to finally do my custom iterators. And I can write this logic however I please. So basically I'm saying next function return value and done. And when done is true, the for loop will exit. If I had a for in, it would exit. But in this case, I'm just using a counter, and I'm just writing randomizer.next, and you can pretty much guess what this will do. It's going to write out 100 random values using a for loop. I think I would probably find this very useful for unit testing with random data, for instance. So that is the next interesting example. Next example, full support for Unicode. And again, Swift was one of the first languages. I'm not sure of this actually, but I know for sure that people were making fun of Swift when they introduced the concept of being able to embed an emoji character inside your code. Like a variable name could be a smiley face, and people thought that's crazy. But now everybody's doing it, including JavaScript, and full support for Unicode. Now, strings in current JavaScript are also Unicode. But the problem is when you do a dot length on Unicode string, it returns twice the length. That's a different problem for another day. But the current version of JavaScript doesn't have full support for Unicode, as in the variable names, for instance, cannot be in Unicode. ECMAScript 6 will allow us to do that.
Does it also recognize, because I'm guessing it's hard in the second one.
Yes.
Does it recognize the sense of reading? Because,
Yes, it does.
okay.
That's Urdu. It does. My Urdu is not very good, but it does, yes.
Yeah, because the last
You can see the last character is the first, exactly. Oops, add block. Okay. Cool feature number 938. The ability to write your code in libraries, which are files, JS files, and then selectively export methods to other files, and then import those methods from the other file. Like this. Import, so this was the top file. This code was in a file called math.js. And this file down here can say, import star as math from lib/math. And then I can say alert 2pi is equal to math.sum, because that is also a method that was exported somewhere. Maybe I didn't copy the full thing. No, math is the library, and math.sum is the method. So I can say math.sum, math.pi, math.pi, and that gives you the value of 2pi. So the ability to structure my code into multiple files and import and export selectively as I choose, something that we've been able to do in every other language on earth for so long. JavaScript will allow us to do that as well. Right? Now there is a concept in JavaScript called promises and deferreds. And promises and deferreds is a very important concept because we are writing a lot of async code. JavaScript natively doesn't have this built into it, but all these libraries have helped us out there. And jQuery has this, Angular has this, and basically the way that works is that I want to be able to write a method that looks like this. So I'm going to call, say, function my awesome function, for instance. The name can be whatever. I'm just going to call it MAF, okay? And then I'm going to say when MAF, then do something. And this will be another function, let's say. It's pseudocode, not real JavaScript, but this is typically how it works. And we use this pattern over and over and over again. Now, how exactly would I implement MAF is that I would say var d is equal to new deferred. This is like, say, jQuery or something would do this. Then I can say, go away. Then I can say d dot promise and then I would exit. Right? So that way, this statement here will execute immediately. And this function will execute later. When? When my work over here is done. So this could be an AJAX call. This is a long-running operation. And when do I specify that my work here is done? Like the $http.post, type in the URL, and then I can in the success callback, and here I can say d.resolve. So when d.resolve gets called, and I have the option of sending return values at that point as well, and they'll be supplied as input parameters to this function, and this is how we've been doing deferreds today. No matter what framework you pick, you were doing an equivalent of this. And this code is hard to understand. It's upside down, and it's too wordy, and especially if these functions get big and complicated and there's logic driven in them, they get hard to maintain. They're better than not having them, but they're still not the best. Like, C# has that await keyword. That's awesome. Now, JavaScript didn't give us the await keyword, but they gave us native support for promises. And this is how ECMAScript 6 will support promises. What I'm doing here is that I have said function timeout. I have a default value here. Just ignore that for now. Return new promise, resolve reject, lambda function, the arrow syntax, set timeout, this. So I'm using the out-of-the-box set timeout method where I'm going to say whatever duration is passed in here, duration, duration, duration. At the end of that, go ahead and resolve it. And now my code becomes so much simpler. So I say var p is equal to timeout 1000, then this thing should print out in exactly 1 second. Actually, let's say 2 seconds or 5 seconds. And int free, go ahead and run it. 1, 2, 3, 4. Well, there you go. So this is another cool thing in ECMAScript 6. So ECMAScript 6 is going to make JavaScript a lot more palatable. And what's happening now is that people are already working on ECMAScript 7. Every year they will iterate. Browsers are going to auto-update So the web is going to be a lot more standards compliant. It'll move a lot faster as we go forward. And that's the future we're looking at least as far as JavaScript goes. And I'm almost out of time now. So with that, I hope at least everybody found something useful in the last 90 minutes. Did you? Was there something interesting and useful? Okay, good. So my name is Sahil Malik. What I'm going to do is that I'm going to upload these slides and I'll tweet the location of them by the end of the day today. My Twitter handle is @Sahil Malik. So you'll be able to download the slides if you're interested. All code, etc., is in the slides. And if you have any, training, consulting needs, you know where to find me. Google for me or go on my site. There's a contact button on the top right-hand corner. And thank you very much for coming. Please remember to leave feedback on the app. Thank you. Call some logic conditionally, etc. So you can see that this is pretty useful. So that is monkey patching. Monkey patching can also be dangerous. This is a technique that is being used by a lot of hackers, where especially you're downloading libraries from, say, CDN. And especially a lot of these websites, they download jQuery from a HTTP URL. I think this technique can be so dangerous that these libraries should not be served on HTTP URL. It should always be HTTPS. But let's say if you're doing a $HTTP call, you make a post request or cross-domain request especially, you can introduce monkey patching where you can tap every single request, send it to another URL, and then call the jQuery $HTTP, and then so the user will never notice, but you're stealing all their data, right? So monkey patching, both useful and dangerous. So that is monkey patching, right? So that is my tip number 1, monkey patching. So second tip, this is so confusing. The variable this in JavaScript is one of those things that it can be pretty confusing, but once you understand how it works, then it's pretty straightforward. You might have seen code that looks like var that is equal to this in JavaScript. So what is this? What is that? And what is an easy way of understanding what this is? The best way to think of this is it is a pronoun. Right? Like this cup is hot. So it is a pronoun, and I'm referring to this cup. Right? And it can change based on context. So this is some sample code over here where I have this random object. It's got a property called tournament, data that is an array, and then a function called click handler. And inside of the function, there's some stuff going on. There's a console.log, and then I have a for each on the array. Right? And down here, I call random object.click handler. Now remember, this random object.click handler over here is really running on the window context, because that's the top level base object. So what happens in this case is that when I call the click handler and I say console.log this.tournament, because the context here is the object, this.tournament returns the masters. Right? But then I go inside and I say console.log this, because now you're in here, the context changes to object window, right? So imagine if this was like a constructor-based function, like if you create a function which you can do new on, then typically this could become confusing, because then at that point during the constructor invocation, you would want to save this variable into that if you want to be able to refer to it afterwards, right? So that is a very, very common pattern we use in JavaScript. So this can be confusing, and this is something important to understand. Number 3, understanding scopes. If there was one topic that I would say is the most important in JavaScript, that is scopes. Because scopes is the number 1 source of errors, and also the number 1 source of power when it comes to expressing yourself in JavaScript. The most important thing to understand is that JavaScript has function scopes. It doesn't have block scopes. Most other high-level languages, because a lot of people come into JavaScript with a background of C++, C#, Java, one of these languages. Okay, let's start. Good afternoon, everyone. How's the conference so far? So, was anybody in my workshop yesterday? Okay, one person. Okay, cool. So, my name is Sahil Malik, and I will be talking about JavaScript tips in this conference. You might have seen from the title, it says JavaScript top 10 tips or something. But then I saw that the talks were actually 90 minutes. So I figured, well, 10 is not going to cut it. So I started adding more, and then I started more. It first became 15 and 20. Then finally got tired of updating the title slide. So I just changed it to JavaScript tips. So at this conference, I have 4 talks. One is a one-day JavaScript workshop, which you need a time machine to go back to. So it was yesterday. I think people liked it, I hope. Then I have 2 talks today. This is the first one, and the second one is after the break in this room too. This one is more about writing code. So we'll produce bugs in this class, and the next one will fix those, I guess. So debugging is very important. Even though I never produce any bugs, I think debugging is a total waste of time. So I just write perfect code. But I think debugging is something we should learn. So that's the next talk. And tomorrow I have a whole day workshop on AngularJS. How many of us have heard about AngularJS? Right. So AngularJS is sort of becoming the de facto platform or framework for JavaScript. It's becoming very important. I have been talking with a company here in London as well to organize classroom trainings on AngularJS. So if that materializes, I'm really looking for probably tweeting, blogging about that soon as well. So if you're interested in that, if you missed that tomorrow, you might be interested in that. And in general, I'm a techie. I work on iOS, Microsoft, and JavaScript. So like a full stack developer. So let's get started. So as I said, this talk is about general JavaScript tips because we all love JavaScript, right? This is so simple. Right, this code, can anybody tell me what it does? Who cares, right? I looked at it, I was like, yeah, that looks pretty bad. I'll use that in the first slide. So in this talk, I'm going to be sharing a bunch of tips and tricks. My editor of choice is Brackets, but as you know, it doesn't really matter what you use for JavaScript. You can use Notepad++ or the visual Notepad, whatever you prefer. So the first trick I'm going to talk about is monkey patching. Monkey patching is a technique where somebody has given you this library or a framework, etc., that you cannot change. But you wish to be able to tap into a particular function or something before that function is called. Maybe you want to introduce your own logic. Perhaps you want to be able to hit a breakpoint based on certain conditions, etc. So I'm going to go ahead and write a function, which is, let's say, add, and it accepts a comma b, 2 parameters. And it returns a plus b. And the theory is that this function I cannot touch, but I want to be able to tap into it, anytime anytime calls this function. So I can obviously call this function like this, and that'll work. It'll produce 5. But if I want to tap into it, what I can do is that I can use a technique called monkey patching, in which I can save the function. Remember, functions in JavaScript are just variables. So what I'm going to do is that I'm going to save this function into another variable, right? And then I'm going to override the definition of the current add, and I'm going to say the current add changes to a new function where I'm going to say go ahead and log the arguments that were passed in, okay? And go ahead and return original add, the original add that I had saved, and apply is a way of calling a function as well, and this arguments. And what this allows me to do now is that when I go ahead and run this, and I think I have the page already running here, but I'm going to start the dev tools up here. Now what happens is that when I call add23, you'll see that it is doing a console.write line before it actually returns me a result, right? So monkey patching is an amazing technique because it allows me to tap into an existing function, a library function that I cannot change. That's one useful technique I can use. Another example is that I want to be able to insert some logic before a function occurs, or insert the debugger statement based on certain conditions, any condition,